This is the 8th and final build in the 5-inch mini quad shootout series, and originally I was planning to bring you this Red 20 RC BDX racer frame. Now I haven't even opened this kit, and I've learnt that this frame design has changed, and so this particular kit has been superseded. So rather than bring you something that you could no longer buy, even if you wanted to, I've decided to go looking for another frame to replace it. Now before I introduce the next frame, or the last frame in the shootout, let's just have a look at what these frames are made of. All of the frames so far have been made out of carbon fibre sheet, so a two-dimensional sheet that is laid in a CNC router, and the shapes are cut out of it, and then we bolt them together to form a three-dimensional quad. So this particular sheet is 4mm, so something like this could be used to make the arms on many of the quads in my shootout. Now this last frame that I'm going to bring you is very different. This is a multi-speed frame from a Queensland, Australian-based company, new small outfit. And I believe the guy that makes it or designed it is involved in boat racing, and he builds boat hulls out of carbon fibre. And the process that they normally use to do that is a hand layup process in a mould, and I think he's applied that principle to this frame, and he's produced a three-dimensional carbon fibre frame. So apart from the little hat here and the camera mount, the rest of this frame is a single piece of carbon fibre. And by moulding it in a three-dimensional shape, we get the strength and rigidity in all axes. So this frame is phenomenally strong and very rigid. So it's a layup process. It involves using a mould and laying the carbon fibre mat, which is like a sheet, into the mould. Some resin is injected, and after it's cured, you can pull a three-dimensional piece out like this. The scary part first, this is a 240 Australian dollar frame plus shipping, which equates to US 175 plus shipping at today's exchange rate. And that makes it the most expensive frame in this shootout by a reasonable margin. But to be honest, with my background in motorcycles and particularly Ducatis, I can honestly say that it's excellent value considering the amount of labour and materials and workmanship that goes into hand building a frame like this. If this had a Ducati logo on it, it would easily be $1,000 to $2,000. So in all honesty, I do think that it is good value for money, and I expect that the rigidity and strength of this frame will shine in the long term. So that is the cost of it. The dimensions, 162mm front to rear and left to right, making it a true X frame, and a cross dimension of 230mm between motor centres. There's our little hat or lid taken off, and unlike our two-dimensional carbon fibre sheet, which is laid between two flat surfaces, in this case you end up with a nice smooth side and a bit of a rough side. And for some people it's not maybe as visually appealing, but that is a byproduct of working to produce a frame in this fashion. So with the lid removed, this is the inside components that you receive. It does come with a PDB and some cable here. It is 12 gauge cable, which does seem like overkill, but there is a PDB there, some nylon standoffs and some steel screws that go through to hold that together. I have removed one of them so that I can remove one of these pieces here. This is like a honeycomb mesh. I think it's 3D printed, and there's a piece of that up the underside of each arm, I think, to help hold your electronics in place. In the case of using a little B 20 amp ESC like that, versus there's the 24 amp KISS ESC. The little B would fit neatly in there, and or underneath the mesh, and then a little slots here allow for a cable tie to run around the outside to hold all that in place, and your ESC would be nice and safe and sound inside of a little carbon fibre shell there. But I'll be using the KISS 24 amp ESCs to keep it consistent with the rest of the builds in the series, and that's a bit larger, so it does protrude out the bottom a little bit. I'm not concerned about its safety, but yeah, it's not going to look quite as neat, and it will mean that I'll need to do away with these honeycomb pieces. But nonetheless, because this is so new and so different, I do want to show people what this quad weighs in its shipped format. So the lid here that it comes with is one option, the standard, we'll call it the racing option. There is another option, and that is this flat top lid that has a 3D printed piece on it. It doesn't come with the 3D printed piece normally, but you can opt to get your lid with a flat top on it to facilitate fitting something like this to hold a HD camera in place. So yeah, choose between your lids, or you can buy this as a spare part. I think the lids are about $20 each, excluding the ramp piece and the Velcro. So in this format, this is also the FPV version, so it has a FPV camera mount here. It is a little bit cheaper if you buy it without that for a line of sight version. But let's now see what this frame weighs. So this is as it's shipped, or as I received it. 120 odd grams there, plus the other bits and pieces it comes with. Comes out at about 127 grams for the frame kit that you would receive. So it'll be a little bit different what I'll be building, because I'll be removing some pieces, and it doesn't come with any motor screws, so you need to source them separately. And the arms are quite thick, so I'll report back to you what size screws you need, but they will be M3 for the 2200 series motors I'll be using. But I'm going to guess they're probably going to need to be at least 6 or 7 millimeters long. So I'll report back to you on that, and I'm going to be building it with a different PDB, the Luminaire one, because I need to mount the 12 volt Pololu for the VTX and camera. And because I'm using a KISS flight controller, I've also got to vary the way that I would build this if I wasn't using one. It is designed with a hole in the back here, that if you were mounting your flight controller with the USB port facing backwards and the flight controller upside down, this hole aligns and you can slide your cable in there for programming. The KISS flight controller doesn't allow you to mount upside down and 90 degrees off, so I'm going to need to have the flight controller sitting up a bit proud here so that I can get the cable in from the side. The lid will still protect it, of course, but it will change the way I lay the components out. So we'll see how that goes as the build progresses. I decided that I wanted the antenna mounted towards the top of this little hat here, rather than have the antenna cable come out the back here and sort of curl up between the props. So I'm going to use a pigtail for the job, but rather than connect it using the SMA connectors, I am going to cut the connector off of here. I've already desoldered it from the VTX, and I'll solder this cable direct to the VTX, and so that I can mount it inside the lid here. I have one of these ZMR 250 landing gear carbon fibre pieces, an old one, and I've glued it in here to create a flat surface to mount the VTX in, or VTX on, and that will end up sitting like so. Now I can either remove the top hat to access the switch to change channels, or possibly I could drill a hole in the side here and then poke a stick or something through to press on the switch to change frequencies or channels. The glue that I've used to glue this in is a special glue I've come across. It's a process. I bought this in Germany at a trade show recently. I have no idea what it says in English or what it translates to, but it's effectively two parts: a powder and this this adhesive or solvent type adhesive. So what I do with it is try and demonstrate it. I've got no idea where you'd buy it from, but you take the powder and squirt a little bit out, make a little pile of it around the two pieces that you want to glue, and then take the adhesive part and drop it on to that. Add a bit more of this to soak up the and that's it, and that forms a very, very hard and very, very solid surface. So just put a bit more of that on. It's a pressure based, I think, so it and basically if the contact type pressure, so there we go, that's not going anywhere. I'll repeat that on the third corner here. This time I might try putting a bit of the liquid on first, and then putting the powder on. It does go slightly warm, but and there we go. That no matter how hard I pull on that, it's not gonna bust out of there. So I guess an impact, a hard impact on the top of this might break it loose, but I'll probably have other issues to deal with if that happens. So that's yeah, I'm not sure where you buy it from in Western countries, but yeah, you might have to use Google and see what you can find. But yeah, it's a two-part thing. I might try and put a link. If I find the website for it, I'll put a link in the description, and you might be able to find it where you live. Next up, I want to weigh the quad and compare it to, so that I can compare it to the weight of the other frames that I've built. So for all of the other frames, I've included a PDB. In this case, I've removed the factory PDB and put a Luminaire one in there like most of the other quads. I've got the nylon standoffs here, and I've replaced the original screws, the steel screws, with some special long titanium ones here, which are very, very light. And it's also, I've replaced the hat screws with some titanium ones. And just to keep the special treatment flavour going, I am going to use titanium motor screws. Now, I've found there's a fair bit of inconsistency in the width of the arms where the screws come through. So in some cases it's 4mm, 5mm, or even 6mm thick. So I'm going to use a mixture of M3 by 6 and M3 by 8 screws, trying to ensure that I don't use any that are too long and screw into the windings of the motors. But yeah, it will get a bit of special treatment in that regard. So the weight of it now, in comparison form to all the other frames, so with the PDB and the nylon standoffs and its top hat and the screws that hold that on, comes in at 116 grams. I've started the build by mounting the VTX in place. First of all, I soldered the pigtail wire direct to the VTX. There'll be a link in the description on how to do that process. And then I put the VTX in some heat shrink, and then I've cable tied it to that triangular piece of carbon fibre that I glued up in there. And then the top of it here, you can see where the antenna comes out. So I can still see the LEDs that tell me my frequency and channel, and still access the button here to change channel frequency. If I drill a hole in the side here, I'll be able to poke something through. So we'll see how I go, whether I need to do that. But once that's mounted on here, I think that the antenna in this position will help to keep it clear of the props a little bit better than where it was originally designed to come out the back here. So that part of the build is now complete. I've started preparing the X4R S-Bus receiver by de-pinning it and putting it in some heat shrink. I've just got a bit of excess cable here. This will wire or solder directly to the flight controller, be cut off a bit shorter of course, and it's got its yellow telemetry wire hanging out there ready to go to the flight controller as well. So, mid-build update, let me show you the process I've gone through. First of all, the battery strap, the original one, it's high quality and very, very strong material, but it doesn't have a D loop in it, which means it's more difficult to get it done up tight. So I've put that aside and I've grabbed one of these Scorpion thin or small straps and passed it through. And that's been the first step, is put the battery strap in place, and then I've mounted the then I've put the 12 volt Pololu onto the PDB, soldered that in place, and then mounted the PDB down inside the body here. The PDB is mounted using the titanium screws, and it's sitting off the base using some M3 nylon nuts, just the standard M3 nylon nuts, and that gives it a space for the battery strap to be passed through. So important to get that battery strap in first, I think, because it will be much more difficult later if you try to install it. The PDB then being in place with its 12 volt BEC, I've put a VBAT wire from the auxiliary 1 output there, which is battery voltage, up to the KISS flight controller, and I've also prepped the 12 volt output from the BEC on auxiliary 2, just comes up to the LC filter, which will deliver power to the camera and the VTX, and that'll sit inside the body there somewhere later. I've put a battery pigtail in place using some 14 gauge wire. You'll notice that the red lead is a little bit shorter, and that helps give it a bit of a twist to loop underneath, and I've kept that short. It goes through the back of the frame, through this hole here, which I think was originally designed to allow you to access the USB port on the flight controller, but because it's a KISS it can't mount in that orientation, so I'm using those holes, or that hole, for the battery lead. I've wired up and connected two motors, the two rear ones, and their ESCs. I'll step you through the process for one of these front ones in a minute. It was a little bit of a drama to work out the best way of doing it, but I'll show you that shortly. So yeah, that's where the build is at the moment. I'll step you through the sequence for mounting the ESCs and motors. It's a little bit trickier as compared to a traditional quad, because the ESC gets buried up inside the arm there, and the motor wires actually pass through the arm, so it's a little bit trickier to get the order right to make sure you can still get your heat shrink on and connect all your wires up. So I've done the two rears there, but I've still got the two fronts to go. So the next one on my list is the left front here, number 1, as per the KISS numbering sequence. It's different for a naze, but this is number 1, and this one should be rotating clockwise. And so here's the bits and pieces that I'll be using for that. Number 1, I've got Luminaire 2206 2350 kV motor, and the first thing I've done is trimmed the motor wires to 75mm or 3 inches. So there's a piece of one that I've cut off, and I've pre-tinned the ends of those wires. I've got my M3 by 8 titanium screws here. I've got a washer on one just to prevent it from screwing in too far and shorting on the motor windings. Now I've found that these arms vary in thickness quite a bit, so I'm using a mixture of M3x6 and M3x8 screws. Here we have the ESC and the KISS 24 amp ESC. I've pre-tinned the connections on that, and I've got a piece of clear heat shrink cut and ready to go. And then I've got the wire, some servo lead wire that's been pre-tinned at the ends, and some 18 gauge black and red wire that also has a pre-tinned end on one end of it. So the motor sequence or the wire sequence versus direction. I've found that when I wire these motors direct to this ESC with the wires coming straight like this, that this motor will turn counterclockwise, so the wrong direction for number one. So I could either cross two of these wires, or on this ESC I can bridge the JP1 connector on that and to reverse the motor direction. So with this build you are going to have to come to understand and prepare your motor direction, or understand which way your motor direction is going to be before you build everything, because I'll need to bridge that JP1 terminal and it will be difficult to get to later. So yeah, that's the bits and pieces that I'll be using. The first step is to mount the motor. So I've passed the wires through the hole in the frame, and using some Loctite 243 there, I've put my two motor screws on. You can see one has the washer on it, and that's to ensure that I don't have too much thread poking through to the other side. So I've done them up tight, and it's only the two motor screws that hold the motors on this frame. And I've soldered the positive and negative power leads and the servo cable onto the KISS 24 amp ESC. Note that the power leads there, the positive and negative, are angled, soldered on an angle towards the centre line of the ESC. There's a bit of a ramped recess in the frame, and so by angling them this way allows them to sit a little bit deeper inside of that recess. I've also bridged the JP1 terminal on this ESC to reverse the motor direction, which for motor number one I needed to do. I've soldered the motor wires onto the ESC, and they're soldered straight through as they were sort of in that position when I had everything laid out a little bit earlier. So it's as if the wires go straight through if the ESC was mounted on top of the arm. And now can be confident that my motor direction will be correct. I threaded the heat shrink over my tangled spaghetti and put that in place over the ESC. I threaded the positive and negative power leads and the servo cable back through the hole in the frame to the centre part, and then I've mounted the ESC in position, slotting it into the arm, and then using a cable tie to retain it. And that 75mm of motor wire, or the excess of that, is curled up here underneath the cable tie alongside the ESC. The final step is the wires coming into the main compartment area. So the servo lead's been trimmed a bit shorter. I've still left it with a few inches on there, and we'll sort that out later when we put the flight controller in place. Now, because it's sitting down inside of a well, it means the soldering iron sort of stands vertical. So you'll notice I've taken the black stand off of this screw here, just so the soldering iron doesn't damage it. And those leads there, where it's labelled ESC3, the power wires for my motor ESC number one, and got a little bit of a loop in them for a bit of excess, but soldering job not as neat as I'd like, but it's a bit difficult holding the soldering iron vertically. Definitely more fingers being burnt with this build than all the other builds put together. I've soldered the ESC servo leads now onto the flight controller. The X4R receiver is being put under the flight controller. It's just been hot glued to the PDB near the 12 volt Pololu, and then soldered up to the flight controller. So the yellow telemetry wire and the S-bus cable come up the top here and are soldered in place. The flight controller is locked in place now using some nylon nuts on the ends of the black nylon standoffs, and I've gone ahead and prepared the LC filter, or the rest of it, and connected that up to the cabling for the VTX and the camera. There it is there. There'll be a link to another video in the description if you want to know how I wire up an LC filter. And the HS1177 camera is fitted. It's held in place just using the locking ring on the camera focus adjustment. The LC filter fitted down the front of the flight controller, and here it is connected to the camera and VTX. So to complete the build, I've put some antenna straws on here. These didn't come with the frame. I bought this straw material from a hobby shop and glued it in the holes that are already there, and then put a slight bend in it, and I'm fairly confident that'll do a good job of holding those in place. The top hat needed to be filed a little bit to allow for those straws, so just a minor bit of filing, only took me a second or two, and the top hat then can be fitted in place. On the underside here, I've put some battery foam here, just cut it out of an old motor box and double-sided taped that in place, and that pretty much completes the build. Now for some post-build review. This is a very new concept, I think, to the world of FPV drone racing, and also especially to me. So there's a few things to be aware of. This is, I guess, considered a pre-production version, and I think they're still ironing out their process, manufacturing process, etc. So it's not perfect, but just to point out a few things that maybe they should be aware of. First of all, the camera mount. I think apparently it was originally designed as a line of sight quad, and the camera mount was added afterwards. It's fairly robust and sturdy, and I can't really see it copping any real impact, except maybe if it landed on a rock. But the adjustment of the camera angle isn't real robust. There's a nylon screw under here, and I've tried to adjust it out, and it's now bent the nylon screw a bit. So it pretty much maintains a fixed camera angle of, I'd predict, about 30 degrees. So there could be a bit more thought put into the camera adjustment there, or how it's mounted to the frame. Another area that could do with some attention and that you should be aware of are the motor mounts. So if I flip it over here, first of all, it only has 2 screws for the motor mounts. I typically build all of my quads using all 4 screws. I know some people only use 2, but in this case it only allows you to use 2 motor screws. Although the top surface of this is fairly smooth, the underside is quite rough, and that's just part of the process, a byproduct of this type of process for carbon fibre manufacturing. But what it means is that the thickness underneath is quite variable. I found it varied by about 1.5 to 2 millimetres, and the screw heads don't necessarily sit flat. So there's chance that the screws could more easily work loose than if it was nice and flat and parallel. In some cases I've fitted washers, and I reckon I'd probably consider fitting washers for all of the screws there in the future. But yeah, a little bit more attention could be given to that. I can't really think of any other way of doing it except for maybe machining it to be flat again afterwards, and at least parallel with the top side. Something else, this top hat comes with some screws, a little M3 by probably 10 screw, and basically they strip out pretty easily. I was hoping to use some little titanium ones, some nice lightweight titanium ones, but yeah, as soon as you try and tighten them up a little bit, they strip out. There's no captive nut in there. It's basically just screwing into a hole in the carbon fibre and resin. So eventually, after taking them on and off a few times, I think they'll work loose very quick, and you'll risk losing the top hat. So as an interim measure, I've taken some small wood screws like this, and I'm using them to hold this little top hat on. The underside of where those screws come through is visible through here, and so I'd need to remove the ESCs and the cabling, which I couldn't be bothered with now, but in the long term I may consider doing some keyhole surgery, coming in and gluing a captive M3 nut on the back side of the frame here, up inside the hole, so that this I can go back to using some M3 screws, and they'll pull down tight. I noted this early on. The ESCs that I've used are the larger KISS 24 amp, and they do protrude out the bottom a little bit. Doesn't look real neat, and that may be disconcerting for some people. The guy that's manufacturing it, I spoke to him actually the other day on the phone, and he suggested that they have the facility to make this longer, and so that may be something they do in the future, or perhaps through special order they can make it with longer skirts that hang down a bit further to protect the ESC. I'm not concerned about it really getting damaged, but it doesn't look as neat as it could. So with these HQ props on there, I've got about 0.5 millimetre of clearance between the end of the prop and this nylon nut at the end of the camera bracket. Interestingly, I did try these Gemfan 5040 tri-blade props, and they just touch this nylon nut here, so I'd need to modify that, maybe fit a smaller nylon nut, or drop the whole camera bracket down and modify it a bit. So yeah, that's running very, very close to there. Now, apart from that, I just also wanted to point out this top hat here. This is the one with the flat top on it that allows you to put a HD camera mount on there. This one here is a 3D printed one that's solid. It's a fairly bulky, chunky thing. This is one that I've come across recently that I'd much prefer. It's actually a fairly flexible material, and having a gap under there means it sort of acts a bit like a shock absorber, and would absorb some impact if you were to run it into the ground or into an object. And it's also a bit narrower, and it's a little bit lighter, so something like that mounted on top there, however it would go, something like that would work quite well. So this, as I said, was about a $20 extra, or you can order it with this top hat. So yeah, it's a good option if you do want to run a HD camera on there. Obviously, for me, I've mounted my VTX up inside the top hat, so for me to change, it's not so straightforward. But if you do go with the original design idea of running the antenna out the back and putting your VTX on your electronic stack, then you could easily change the tops over without any trouble. Now to weigh the quad. I'm weighing it with props, VTX antenna, battery strap, etc. So it's basically ready to fly, and like I've weighed all the other ones, let's have a look. 335 grams for the quad without a battery, and when I add a 1300 4S battery there, it comes out at 512 grams. I sat back and took a look at the bracket that holds the HS1177 on, and I decided I was going to try and fit the standard factory HS1177 U-shaped bracket that comes with the camera. And so I used my special German adhesives here. and glued it to the carbon fibre frame, and yeah, there's no way it's coming off. Yeah, I'll have to grind it off if I want to remove it, but that's now on there. It was difficult to get the screwdriver in then to tighten up the screws on the side, but I did get it eventually, so I've now got that bracket on there, and that provides a lot more clearance to the props. It's a lot easier to adjust, and I have more adjustment. So I was really struggling to get 45 degrees out of the original bracket. With this one I can, well, go all the way to 90 degrees, so I've got the full range of movement with it now, and picked up extra clearance. And as a bonus, I've cut the weight down a little bit further, so let me move these glues out of the way. So now the quad with a modified camera bracket here is 331 grams without a battery, and when I add a 1300 Graphene 4S battery, it comes out at 505 grams, so that's about a 7 gram saving over the original bracket. And this video seems never ending, doesn't it? So since I've fitted the different camera bracket here, the original 1177 bracket, I picked up a bit of extra clearance, so I thought I'd try fitting some 6-inch props, and as you can see there, they actually fit and I have clearance. So it's not much to the camera there, but it'll do the job. So this quad technically probably doesn't fall in the category of being a 5-inch quad, since it will allow the use of 6-inch props, but I will be testing it with 5-inch props for the sake of the shootout. But at the end of the shootout I'll probably strap these 6-inch props back on and see how it flies. These are pretty aggressive, being a bullnose prop, and with the 24 amp ESCs I think I'll probably run into current limiting issues, but nonetheless we'll give it a go.